My name is Sean Klingensmith. I work at InterSystems in the data platforms development team, working primarily on our security architecture. So today I'm going to share some information about a couple projects that we've worked on last year that to help secure and properly manage sensitive information in IRIS. And talk about how this lays a foundation for some of the future work we'll be doing in the next coming versions. So let's get started. So the first thing I want to talk about is the security database. So this is a project that we completed in IRIS 2025.2. So if you've run a recent version of IRIS, you already have this. So what this is we created a separate system database in the system to store the security configuration. So think of things like your user definitions, application definitions. Really, if you're familiar with our security APIs, so any of the security.classes in the sys namespace, as well as a couple other classes. So we moved the storage for those into a different database called IRIS Security. The reason for this is to provide, like I said, more secure storage of that information, so you can segregate that out. So it's a separate database with a separate database resource, DBR security, and this resource can't actually be granted to any users. So it can't be granted to a role other than the system configured DBR security role, and that role can't be granted to any users directly. So no one will have direct access to the security database. You can be sure that no one will be, users aren't going to be mucking around with the globals that store these tables. All access has to come through the InterSystems APIs. So the APIs there are the same APIs that we've always had, the security classes, the management portal. You can create like users and roles through SQL. That'll all work fine. But you can't come in behind the scenes and try to mess with the globals. This will help maintain the consistency of that data and make sure any access is audited appropriately, et cetera, and that we can apply the appropriate resource checks. And the way this works is when you're coming into the APIs, we will check that you have the appropriate resource, usually admin secure or maybe one of the granular OAuth permissions. Then our code will escalate to give the process read-write access to the database in order to do the operations. But then that permission is removed before it returns to your code. So again, to provide better storage. It shows those APIs. So that's the core of the feature. Is like not something particularly it's going to be you'll be using or seeing necessarily, but it will help secure your system a little better than it had been. But this also gives us additional capabilities in the system. So since this is a separate database outside of IRIS, this database can now be encrypted. And again, you can do this now. You can use any of the database encryption mechanisms that were just talked about in the previous session, if you're here for that. So now you can encrypt our security database as well as the other system database like your IRIS temp, IRIS local data, and of course your application databases. So this will, if this is part of your threat model is doing database level encryption, you can now encrypt your security data here as well. One of the things that we don't have implemented yet but are working on is to allow you to mirror this database. So you're able to enable mirroring for your security configuration that will be able to be shared across your mirror environment. So your DRs, your failover members will be able to share the same security configuration. You won't have to duplicate that configuration across different nodes. So you'll automatically have that sharing. This project is currently underway. It's actually in testing, so this will be coming out later this year. So you can look forward to that. Just to talk briefly about that. So again, it's mirroring the IRIS security data. So again, on your non-primary members, it'll be like all mirrors, it'll be read-only. So your configuration will be done on the primary, then it automatically gets replicated on your non-primary instances. So again, this is trying to think of things I can say about this in a quick time period. This is a project I've been working on a lot. So if you have any further questions about this, I'm happy to talk about it. Come track me down, send me an email. This is something we're really excited about in the future, but I don't have time to give all the details right here. Going along with that, We want to make this ECP mountable as well. So again, you can, this will allow you to share the security information across your cluster, your IRIS instances. This is really something we're working on in this and a couple other projects to sort of make that configuration and cluster management a lot easier. So this is another thing to look forward to in the future. So before I move on, any questions about that? About security wallet or security database? Moving ahead, yes.
DSMs that you set up, is that going to be part of security?
Is the what do you mean by DSMs?
SQL connections, like.
Oh, the SQL. Yeah. Okay, yeah. So the question is about external SQL connections and where that's stored. So currently, those are stored in IRIS still. They're going on. We're going to talk about the wallet in a minute. That's your credentials. Those are stored in IRIS security. So that adds a little bit of friction there. But we are working on. We have plans to sort of rework the way the SQL connections work.
Yeah.
So yeah.
To get those connections mirrored across.
Yep. Yeah. So that's not going to be in the first iteration of the IRIS security mirroring. Is a short answer. Yeah, over here. So mirroring should be this year. Again, project is currently in testing. So that'll be done soon. ECP. Oh yeah.
Project late next year. All timelines subject to change.
Sorry, I forgot I had product in the front to defer the questions to. Any other questions before I move on? We'll have a chance at the end too. Okay. Yeah, so the next thing I'll talk about, so again, we have this new security database that allows, it's like API only access instead of relying on the underlying DB resource. So this actually allows us to have a secure way to store credentials. This is something we've wanted for a while. One of the motivating features was the SQL gateway connections. So where we store credentials to talk to an external system, we want to be able to store those credentials in a more secure way. So that is a feature that we're calling a secure wallet. You can think of this is a secure credential store inside of IRIS. So it's something, anytime you want to store credentials to connect to a third-party system to use with maybe a REST service, maybe an SQL gateway connection, storing passwords, API keys, things like that. They need to be stored for semi-permanently. Maybe you're not going to be using access tokens and OAuth tokens because they're short-lived. Maybe it doesn't make sense. For that, but for other type of credentials, it makes sense to stick in here. This defines a flexible storage, so you can really store whatever you want, but it's designed particularly with credentials in mind. It allows you to have configurable access controls, so you can specify. So it has, following the IRIS security model, you have resource-based access controls. So you need access to a particular resource in order to create or edit or use the secrets you store, and you can configure them so a user can have access to some secrets and not other secrets. They can have access to use it but not edit it, things like that. We'll talk about how that works in a minute. And then we have this feature for if you're going to use the credentials with InterSystems APIs, say net.http request, in order to make a REST call to something, you can configure it so that that secret cannot be exposed to your code. So you'll essentially just associate that secret to your HTTP request. And then our code will look up the password, attach it to the request, and send it to the third-party service. Your code never sees the password, the secret, the API key. So the advantage here is you don't have to worry about accidentally exposing the secret, putting in a log file, someone finding it from a mistake in your code, because your code never had it to begin with. So it allows better access controls if you're in that situation where you are using our APIs. If you're storing a secret that you need to then have your code process, you can also configure that. But again, you're taking the responsibility to manage that appropriately. So that was fairly high level, so let's get into some more details. Overview. Yes, so what we've implemented here is an ObjectScript API that you can use to create these secrets. A secret lives in a collection. The collection is where we define the access controls. A collection has two resources you specify. You can specify an edit resource and a use resource. As you could maybe figure out. The edit resources, what you need access to this privilege to create, modify, delete any secrets inside the collection. And then the user resources, what you'll need in order to access that secret, however that secret defines its access. Once you have a collection, you can then create a secret. Again, this is %wallet.secret is the class. Like I said, a secret always lives in a collection. The collection name is actually part of the secret name. So the secret name will be collection dot whatever local name. So the secret has that sort of one-to-one or one-to-many. It's that one connection. A secret lives in one collection. So then you can store multiple secrets that have the same sort of security characteristics in the same collection. If you wanted, if you want to have permissions for on a per secret basis, you could just have a collection with one secret. Anyway, so Wallet Secret is an abstract class. So we have a couple different implementations of this. The most useful, I think, most flexible is key value. This allows you to store a set of key value pairs. Again, think username and password. Think API key. You can have any number of secrets you want. You just express, or keys, that key value pairs that you want. You just express it in a JSON syntax when you create it. We'll give an example in the next slide. So quick overview. Any questions about that? Maybe an example would help. Okay. Yeah. Yes, the question is, are there any other secret types? Yes, I have. There's one for symmetric keys that you can use for doing symmetric key, think AES encryption, and one for RSA you can use for signing things. I think the key value is probably the one that's going to be most used, so it's the most flexible. Yeah. Yeah. So here's some example code. You can see how you'd create a collection. Again, the top line you see %wallet collection create. You specify the name and then your resources that you would use. So you see here wallet demo manage and wallet demo access. These are security resources in IRIS that need to exist before you create the collection. And you can specify the permission you want. It could be any of use, write, or read. If you wanted, they could be the same privilege if you wanted the same permission structure for creating, editing versus using. Once you have the collection, then you can create a secret. In this case, you create a key, or I'm creating a key value secret. Look at the first line. Again, references the collection in the name, demo.kv1. You see the last parameter in there is secret. That specifies the key value pair, so your username and password. Associated with the secret, you also have some metadata that you specify. The most important here is usage. You can specify how, that again defines how this can be used. HTTP means I'm going to use this with a %net that HTTP request object to do, say, a REST call to some other third-party system. Custom means, was the case I mentioned earlier, where I'm going to have code that needs to look at that secret, so you'll need to be able to expose it to me. If you don't specify custom, there isn't a way for your code to call and retrieve the secret from the secret, to say the sensitive information from the secret. So it would be, yeah. So let's say you create it, and then a quick example of how you would use it. So in this example, at the beginning, you see how you would attach it to a %netted HTTP request object. Again, use this method use secret to associate the secret you just created, which I think has a different name. Yeah, I should have said demo. That should be demo.kv1. And it's saying I'm going to use it with HTTP basic authentication. What this will do is it looks in the secret that I specified, look for a key named user, key named password, and create the authorization header to use. It'll support, we support basic authentication. You could specify a value, so you can arbitrary HTTP header. There's syntax for that. There's syntax for putting in HTTP form fields. So there's a number of ways you can attach find the value in the secret and associate with the HTTP request, depending on what you're trying to do. That's the HTTP case. If you're doing custom, you can see the second example where we call just get secret value. That'll just return the set of key value pairs from the secret that you specified that you can then use however you need. Any questions about that? Oh, yes. The question is this mirrored with the database? And the answer is once the IRIS security database is mirrorable, it will be mirrored with the database. Yep, because it's stored in security data. Yes.
So when you call get secret value from a custom,
Yep.
how is it being returned? Is it just a comma delimited value where you have, or an array, or
Yes.
how do you get the user and then pass
Yep.
it?
Yeah, so the question is if you're doing a custom type secret, you call the get secret value function, what does it return? It will return the JSON, it's returned in JSON format. Yep. Yes.
If I want to store secrets that are per user,
Yep.
do I need to create a collection prefixed by user name and a security
Yep.
resource per user in order to do that? Have you considered a mechanism that says there's a syntax for a collection that says this collection is private to this dollar username, and so if I'm authenticated as John M, I can see my secrets, but nobody else can see my secrets.
Yeah, so the question is there a way to specify the secrets to be specific to a user versus another user? And the answer is it uses resource-based security. So you have to specify a resource, and so in order to implement that, you would have to have a resource per user and do that. Yeah, yeah. Yep.
Security resource to another user and they can get my secrets.
Yes. So it's based on resources, not based on the dollar username of the user. Right. That would be moving it more towards the. So we have two security models in InterSystems IRIS. One is the core security model using resources and users and roles. There's the SQL security model based on a grant things to a user or a role to a privilege on a table or whatever. This would be moving it more towards the SQL security model. Just an observation. Any other questions? So you got way too wide. The question is there anything in the tool that prevent printing of the secret? So, in the context of zero trust. So, is what I'm trying to get at with the usage specification. So, if you're doing it for HTTP usage, or I have a usage for SQL Gateway to use it with an SQL secret, then yeah, you're not exposing the secret to the calling code. It's all handled inside the InterSystems library, so you have that protection. But if, on the other hand, if you're doing the custom thing, like there isn't a way to do that specifically. Yeah. So it does have the way it works under the hood. It'll pull up the secret and do what it needs to do with it, and then do away with it. It doesn't keep it in memory longer than it needs to. Like it'll go read it from the global every time, etc. So you don't have to worry. So we try not to expose it any longer than it needs to be in memory. But yeah. I have any questions? I think I have one more slide. So I just want to talk about, again, the future. So this is sort of the core implementation of the wallet. One of the things we want to do, we'd like to support external secrets managers. So you could end up retrieving secrets from something like your HashiCorp Vault or AWS Secrets Manager in order to use those inside IRIS. That's one thing we are working on. The other roadmap thing is just trying to use this. We're using this internally and across the InterSystems product libraries, trying for all of our secrets management needs. So we can look for, if you're familiar with the ENS, the interoperability credentials, so ENS.credentials. So those will be moving to the secure wallet instead out from the existing ENS credential structure. So like that sort of thing, we're trying to consume this internally to again better protect secrets across our platform. So that's what I have. Any questions about anything? I think I have, I guess, not much time. Maybe one question? Oh, yes.
Besides custom and REST, what other areas have that?
Yeah, so initially we have custom REST SOAP, which is basically the same as the HTTP, but for a SOAP client. And then a special type for SQL Gateway credentials to use with %SQL connection. So Those are your predefined like DSN or JDBC connections to external databases. Yeah.
Is that going to be integrated anywhere for the business operation?
Yeah, yeah, it's the ENS credentials. Yeah, so we're working right now to have your ENS credentials objects be stored in the wallet. So you'd still, I think you'd still have the same user experience for like creating the credentials inside ENS credentials, but under the hood they're stored in the wallet instead of storing it in the secondary database. Yep. Sorry, the question was about are we going to be using it for interoperability productions, etc. Okay, so I think I'm out of time. So if you have any other questions, anything you want to talk about, feel free to find me. This week I'll be in the developer community. What are they calling it? The Tech Exchange. I forget how to talk when I get in front of people. I'll be in the Tech Exchange. Feel free to talk to me or send me an email. And thank you.